Good afternoon, everyone. Welcome back to the channel. Time for some more late lunch study. Hope everyone is having a good week. Good afternoon. Today, we're going to try to make our way through the Jeremy IT Labs Day 38 lab on DNS. So I think this is the last IP services protocol that we are going to go through in preparation for the CCNA. And for those that aren't aware, DNS stands for Domain Name System, and basically it's the system by which we type human readable names into the address bar, like for example google.com, and that name gets translated to an IP address, IPv4 or IPv6, so that our computer can make a request to the proper server that it's looking for. So a translation from human readable to computer understandable. That's what we're doing with DNS. So this looks at first glance to be a pretty short lab. So let's just get started. All right, so reading through the steps. First of all, what do we have here? We've got, looks like 3 PCs connected to a switch, connected to a router, connected to the internet, and it looks like we've got a couple servers on the other side of the internet. 1.1.1.1 I assume is going to be the DNS server, which is a kind of a standard naming or IP addressing scheme for DNS servers. I think Google's 8.8.8.8 if I'm not mistaken. And then of course youtube.com. So looks like these are all configured and connected. I am curious, first of all, if we can just try to ping something. Terminal command prompt. What do I want? Command prompt. Can we ping www.youtube.com? No, could not find the host. All right, so just to validate that nothing is working right now. All right, so first things first, configure a default route on R1. So let's get into R1. And we'll jump onto the CLI. Looks like interfaces are up. EN, conf T, we go into configuration mode. And I think IP route. And for default routes, we say 0000, 0000. And then the next stop IP address is going to be out to the internet, 203.0.113.2, it looks like. So let's try that, 203.0.113.2. And that would appears to have worked. So do show IP route. Do we have a default route? Yes, gateway of last resort is set to 203.0.113.2 to all networks. All right, all addresses. So that's done. So let's see if we can now, just from PC3, for example, ping server 1.1.1.1. I'm curious about that. Command prompt, ping 1.1.1.1. Request timed out, request timed out. All right, and we got some responses back, which tells me we had to do ARP resolution probably on both ends, and therefore lost 2 packets. So now we've got 4 that have come back successfully. So if the pinging works, we could ping across the internet, across the network, through the switch, through the router, and we've got default routing enabled. All right, so configure PC1, PC2, and PC3 to use 1.1.1 as their DNS server. All right, let's jump into PC1, desktop command prompt. Let's see. I don't know, actually. I don't know what it is for Windows. ipconfig/all. Oh. All right, so the first things first, we don't have a DNS server enabled, so that's how we would be able to tell if we did. actually, you know what? It's probably not even here at all. It's probably on the configuration panel. It is. Okay, so what did it say? Configure PC 1, 2, and 3 to use 1111 as their DNS server. Fair enough. 1.1.1.1. I think that's it. All right, let me try PC 2. Config DNS server 1.1.1.1. And PC 3. Config DNS server 1.1.1.1. All right, nothing for IPv6, doesn't look like. So now that we've done that, can we ping youtube.com? I'm curious, because now that a default route is configured on the router and we can ping through it and we can target a DNS server, will that DNS server resolve youtube.com's address or a human readable name to an address? So let's try that. Again, ping youtube.com. What if I just do youtube.com? Pinging 127. Okay, so now we do get an address, request timed out, and then we got some back. So DNS is working, hooray. There was one request lost due to ARP resolution, but after that, we called out to the DNS server. It responded with an IP address for our human readable name, youtube.com, and allowed us to create that TCP connection with the server that youtube.com was hosted on. And I just want to make sure I'm not lying when I say TCP connection. Is ping, it's got to be, is ping TCP or UDP? Internet Control Message Protocol, ICMP. Yeah, see, I was wrong on both accounts. Ping is an ICMP protocol, Internet Control Message Protocol, so I was wrong. Tricky. Okay, so that's all set up. Good. Let me just move this over to make it a little bit more visible. Configure R1 to use 1.1.1 as its DNS server. Configure host entries on R1 for R1, PC1, PC2, and PC3. Ping PC1 by name from R1. All right, so we are in R1. So now this is going to be Cisco iOS, not Windows. So here, I think we're going to use a command name server. IP DNS question mark, no. DNS question mark, no. IP question mark, yes. Domain names. Define the default name, domain lookup. IP route, add an entry to the IP host file, name server, yes. All right, so IP name server, specify address of the name server to use. I think that's what we want in this case. Configure R1 to use 1.1.1.1 as its DNS server. I think that's what we want. 1.1.1.1, anything else, question mark? Negative. All right, IP name server, I think that's what we want. And yeah, okay, so we have configured R1 to use 1.1.1 as its DNS server. Okay, so now I should be able to ping youtube.com, and I should be able to successfully do that. It resolves to the address using the 1.1.1.1 DNS server. All right, configure host entries on R1 for R1. Okay, so let's first of all figure out how to do that. IP question mark host question mark name of host. Yeah, so IP host is how we add an entry to the host's file, which is a kind of like a hard-coded mapping between an IP address and a human-readable name for a server or some kind of device. And so we will hard-code these, it looks like. So First of all, I want to say do show IP hosts. IP host maybe? How do I show hosts? Show hosts. All right, so currently we've got one host in the host file and it's got an IP address. It's temp, and I think that's because it was learned by DNS. And so I think if we configure some hard-coded ones, there'll be a different flag here, I would assume. So do show IP host, no, do IP host, no, what am I doing? No. IP host, question mark, name of host. So R1, question mark. All right, and then what is the IP address of R1? So it's kind of weird. Which IP address of R1? Because it's G00 has an IP address, and it's G01 has an IP address. Now, I assume I'll want to use the G01 because that's what the 3 PCs will be able to see. I think I'm going to go with that. R1, and so that's going to be 192.168.0.254. IP host R1, okay. And carriage return, host IP address, yes. All right, do show hosts. And we've got a permanent one for R1. All right, so the same thing for the rest of them. So for PC1, same thing, IP host PC1, and that's going to be 192.168.0.1. IP host PC2, 192.168.0.2. IP host PC3, 192.168.0.3. All right, now ping PC1 by name from R1. So do ping PC1. Sending 5, and we are successful. So ARP resolution occurs, we drop 1 packet, then we get all 5 on the next try. All right, and let's just go ahead and check the host file or the host table on PC or on R1 here again. And we've got all of our hosts with their IP addresses. Can I ping myself? I'm just curious. Do ping R1. What is that going to do? Can you ping yourself? Yes, you can. It's weird. I guess it makes sense. I don't know. It doesn't really make that much sense to me, but I guess it makes sense. Ping PC1 from R1. Okay, that's done. So now, from PC1, ping youtube.com by name, analyze the messages being sent. Use simulation mode for this. All right, so simulation mode, PC1, desktop, ping youtube.com. All right, so now let's just put this down here, whatever. All right, and we're gonna play it. Oh, you can hear my kids screaming. All right, so first of all, let's pause it. Like, what is this? Can I look it up? Gigabit Ethernet 01 receives the frame. Source R1 outbound. Next one. Goes to the internet simulation panel. Okay. So now, last device is the internet. What is it? Is it a DNS request now? Ethernet IP header. Okay, layer 7 DNS. In layers, out layers. Inbound PDU. I'm looking for something that shows specifically, okay, here's the DNS header, DNS query, youtube.com. All right, so this looks like a DNS request, requesting youtube.com. outbound PDU details. Does it provide the address yet? No. Let's do the next step. All right, now let's check it. Does it include the address now? Outbound PDU details, source, destination, UDP, DNS header, DNS query, YouTube, DNS answer, and it's got the IP address. So that's pretty interesting. So all of that included here in this message. DNS answer. Okay. Next to R1. Okay, so the DNS server has now gotten the message that PC1 would like to access youtube.com. It's responding with the message showing the DNS response with the correct IP address. All right, so I assume we'll get to the switch and then back up to PC1. PC1 then knows the name of the, oh, I didn't realize you could scroll over and see all these. These are all DNS types. Okay, so now it's going to know, okay, now I know what I need to ping to get to youtube.com, and I assume this thing will go back over. You can hear my dog barking. It's ridiculous. All right, and then go to the internet and up to youtube.com because now we know the address. All right, blah, blah, blah. And then I assume, oh, the ICMP packets are being exchanged, etc. There's probably going to be 5 of these, and they'll just keep going until we're done. So let's let the whole thing play out. It should keep going. If I can speed it up, does this make it go faster? Play, pause, play. Oh, that does make it go a little bit faster. I wonder, okay. Kind of interesting. We'll go even faster. One, two, three, four, 5 of them. Now this stuff, this must be maybe like spanning tree, or no, I don't know. One of the protocols that has to do with switches. STP, I was right. STP. Interesting stuff. Okay, just kind of one of these times I just want to kind of, oh, CDP. I'm going to learn about that. I haven't looked at that in a while. All this stuff that goes on, all this kind of chatter that makes sure things are configured correctly and everything's hooked up in the most efficient manner is very interesting. All right, so enough of that. That was it for the lab. Pretty straightforward. There was only a handful of commands. I don't even know if you have to configure DNS on the CCNA. You might just have to know a little bit of the theory behind it. But thank you, everyone. I hope you enjoyed this little lunchtime refresher on DNS. And I think next up, we will be getting into access control lists. So that's actually kind of like a bigger, meatier topic for the CCNA. So I'll be back with that soon. All right, have a good afternoon, everyone. Thank you. Have a good night. Bye.